Hello. In this video, we will do class 10th Maths NCRT chapter 1. It is chapter 1 Real Number Exercise 1.3. Exercise 1.3. Okay. Exercise 1.3 class 10th NCRT. Okay. So earlier video we have done question number 1 and 2 that depend on rationality. Okay. Irrationality. So how to prove irrational number root 2, root 3, root 5, that is a root of a prime number is a irrational. Okay, by using contradiction method. So continue that question. So now we are reaching over there that question number 3. Now in this video we will do question number 3. So question number 3 is proof that the followings are irrational. So earlier video question number 1 and 2, question number 1 is proof that root 5 is irrational, and question number 2 was uh, 3 plus root 5 is irrational. Okay. Okay, so same process I'm doing here, and it make you easy how to do these types of a question, and these type of question comes in your board examination for 3 marks. Okay. Now prove that the followings are irrational. Okay, so first is 1 by root 2. Okay, so let us assume. So first is let us assume by contradiction method. Let us assume let us assume 1 by 2 is rational. Okay, is rational. 1 by 2 is rational. Okay, so where rational it means, so 1 by 2 root 2 is equal to p by q, where p and q are integers and coprime. and coprime they are both are integers and coprime. Okay, so now if 1 by 2 is equal to p by q, okay, then now we are doing now it can be written as root 2 is equal to q by p. Root 2 is equal to q by p. So since p by q is is rational, then q by p is also rational. P by q is also rational. Okay, q by p is also rational. Okay, no problem. You have a no problem with it. Okay, now but what the root 2 is irrational. We have earlier proved that root 2 is irrational, but it gives contradiction. But this gives contra but it contradicts, but it contradicts that but it contradicts that root 2 is irrational. Okay, it is a contradiction. Okay, so our assumption is wrong. So our assumption is wrong. Hence 1 by root 2 is irrational. Root 2 is 1 by root 2 is irrational. Okay, any problem you have? Any problem? Okay, let's do the question number 2. Let's do question number 2, that is 7 root 5. 7 root 5. Okay, let's do it. So let us assume, let us assume root 7 by 5 is rational, is rational. That is, so 7 by root 5 is equal to p by q. This implies that root where p and q are integers and coprime, and coprime, integers and coprime. Okay, so this implies that root 5 is equal to p7 by q. p7 by p by 7 cube, since p by q is irrational, is rational, so p by 7 upon q is also rational, also rational, is also rational. P by q is also rational. Okay, no problem you have. Okay, but okay, so now we have earlier proved that root 5 is irrational. Okay, so it gives a contradiction, but so root 5 is also rational, rational. It gives, but it gives contradiction, it gives contradiction, it gives contradiction, gives contradiction. The fact is that it gives a contradiction root 5, it gives contradiction, the fact, that the fact that root 5 is irrational, root 5 is irrational, but it gives contradiction, the fact that it gives a contradiction of the fact that root 5 is irrational. Okay, so 7 by root 5 is irrational, root 5 is irrational. Okay, so again, what we have done in the question number 1 and 2, the similarly we have done in the question number 1, assume 1 by root 2 is rational. Okay, so reverse of 1 by root 2, it means root 2 is p by q by p form, it means p and q is also rational. Okay, but root 2 is irrational, and it gives a contradiction, LHS is not equal to RHS. So what we have assumed, 1 by root 2 is a rational, so our assumption become wrong. 1 by root 2 is not a rational, it is irrational. Same procedure comes in the question number 2. Let us assume 7 by root 5 is rational. 7 by root 5 is rational, so 7 by root 5 is equal to p by q, so root 5 is equal to p upon 7q. Okay, now the RHS is in the form of p by q form. RHS is in the form of p by q form, it is in the form of p by q form. If it is a form of p by q form, it means it is a rational number, and if it is a rational number, then p by 7k is also rational number. Okay, here also LHS is not equal to RHS because root 5 is irrational. We have earlier studied that root 5 is irrational. So what we have assumed before 7 by root 5 is rational, it becomes wrong because LHS is not equal to RHS. Hence, if root 7 by 5 is not a rational, it is irrational. Okay, now come to the last question, that is, so last question is, the third one is 6 plus root 2. 6 plus root 2. Let us assume let us assume 6 plus root 2 is equal to p by q form, that is rational. Okay, so it is a rational. So so root 2 is equal to p by q minus 6. Okay, so implies that root 2 is equal to p minus 6q upon q, p minus 6q upon q. Okay, so since since p and q are integers, q are integers p and q are integers, so what we get p minus 6q upon q is also is also rational. So whatever we are putting here, if you are putting here 1, so 1 is a integer, so p minus 1 yani 1 minus 6 is equal to minus 5 upon 1, so minus 5 upon 1 is also a rational. Okay, so p and q are integers, so we what we get by putting the p and q, the that will also be a rational number. Okay, so it's also rational, but it gives contradiction, but but it gives contradiction, it gives contradiction, that is contradiction, con- contradiction, the spelling of contradiction is, but this contradict, but this contradicts the fact the fact that this contradicts the fact that root 2 is irrational, root 2 is irrational. Okay, if root 2 is irrational, it contradicts the fact that root 2 is irrational, so our assumption become wrong, so our assumption becomes wrong. Hence hence 6 plus root 2 is an irrational. Okay, so now these are the answer of question number 3 of exercise 1.5 chapter 1 real number NCRT class 10th. Okay, now in the next video we will start revisiting of rational number decimal expansion. Okay, so now thank you. Any query you will make comment on a comment box. Thank you.